So once again a very good morning to you all. This is Professor Shripad Desai from the Department of Electrical Engineering at Bharati Vidyapeeth College of Engineering, Pune. This is our video lecture number 22. The topic for presentation today is we'll be discussing about power factor, what we know in detail and its impact on the quality of power. So to begin with, the contents for the presentation include starting with the introduction. We'll be introducing ourselves to the concept of power factor, the power triangle, its impact on the quality of power. We'll be moving ahead with power factor compensation. What are the impacts of low power factor? What techniques can be adopted to improve the power factor? And finally, we'll conclude with a design of a capacitor bank. So we all know what is power factor. It is by definition it's a numerical value of the cosine of the phase angle between the voltage and the current. So it's a relation between the voltage and the current. So power factor is denoted by cos phi, and also it can be represented by the real power as a component of it, as in Vi cos phi. The apparent power, we denote the apparent power by Vi, and the power factor, depending upon its phase and magnitude, can be categorized as lagging power factor, leading, or unity power factor by the relation of current and voltage, which is well decided by the load which is connected and the operating system. Further, the operating power factor is to be given prime importance, as it is directly relates to the operating performance, efficiency, and heating related concerns of the equipments. The issues related to the power factor arise due to nature of operating loads, like capacitive loads, which generally tend to have a leading power factor, inductive load, which form a maximum part of the load in the system, which contribute to be a lagging power factor, and resistive load, in which the power factor being nearly unity. The best example can be use of resistive heating elements in the term of a tungsten filament lamp or a heater. So why are we so concerned about power factor? Power factor has adverse effects. If the power factor is low, it's going to have adverse effects on various power system equipments. Like low power factor can lead to excessive heating. If a particular small scale industry is not maintaining its power factor in specific limit, it can be penalized. That is the importance of power factor, and today everyone is concerned about the quality of power which is delivered, and that also relates to the power factor. While designing various mitigation techniques, like in the previous lectures we have discussed about various mitigation techniques, like implementation of capacitor banks or implementation of harmonic filters. All these devices are basically, the prime concern is designed with respect to the expected power factor, the objective being improvement in the power factor. So we'll try and discuss ahead. This is nothing but the power triangle. It's pretty clear to us that what is a power triangle. Power factor formula wise can be the ratio of the real power to that of the apparent power, Vi cos phi divided by Vi. That gives us the power factor. From this, and making use of theorems, we can make use of various other components can be found with respect to the power triangle. What is power factor compensation? Now, power factor correction aims to improve the power factor and hence power quality, utilizing capacitors to offset usually inductive loads. For examples, motors. Power factor correction system increase the efficiency of power supply, delivering immediate cost on electricity. Today, users as well as utilities, everyone is concerned about the present power factor. The objective being to improve the efficiency of the system, to reduce the heating losses, and to obtain optimum performance. Now, there are certain indications which a power system engineer, technician can get, which is a clear indication of of a low power factor. Some of the indications may be motor failure. The motor is not taking its rated speed. It is working abnormally. It's overheating. It's not able to give its optimum performance. These many may be the reasons of indication with respect to the motor for need in power factor improvement. Further, nuisance stripping of circuit breakers or fuses can again be a very good indication to the technician, to the engineer, of requirement of improvement in power factor. Unstable equipment operation, as in unstable speed, excessive overheating, vibration, noise. Further, overheating of transformers, switchgear and cables. Again, these can be a indication for the power system engineer. Complete or partial failure of electrical or electronic equipment. High energy usage and cost also relate to power factor. Like today, when it comes to tariff, there are power factor based tariffs employed, so this can relate to the cost of the system also. We'll try and proceed ahead. Now, what are some of the causes of low power factor? They may be making use of inductive load on a very high scale. That may be one of the primary reasons. Like most today, we know, like most of the machines, 90%, 95% of the machines which are used are induction based. So most of the induction motors, like single and three phase, they both operate on a lagging power factor and at low loads, and are primary, and if they are operating at low loads, they are the primary reason for low power factor. So that's the primary reason of low power factor. Apart from that, making use of arc lamps, electric discharges, lamps, heating furnaces, which operate at a low power factor. Further, the load on the power system is also varying, which keeps on varying throughout the day. During period of light loads, the supply voltage increases and magnetizing current increases, leading to lower power factor. So these are some of the causes of low power factor. We'll proceed ahead. Power factor improvement equipments. Which are some of the equipments which we can use to improve the power factor? Now, normally power factor meters are present. We can also make use of power quality analyzers to check whether the power factor of the system is really in the desired limits or not. Like apart from that, we also can make use of various measurement devices and make use of the power triangle to find the power factor by a different method though. But making use of power factor meters, power quality analyzers will be able to give us the reading, the power factor reading in the real time. And also a power system engineer can analyze the condition under various load conditions, switching conditions, and in various time of the day, as to give him a clear indication, a clear idea of what being the real cause of low power factor. So that is also important. So you can make use of a power factor meter or any power quality analyzer. So we were discussing about the improvement techniques, power factor improvement techniques. So first and foremost, the simplest amongst all is making use of static capacitors. So they are more simple, cost effective, and they are basically easy to design as compared to others. So static capacitors is one such option available to the power system engineer. Further, making use of synchronous condensers. Now the problem with the synchronous condensers being very large in size and they make continuous noise. So although it's a improvement technique, but it also comes out with some drawbacks. Also there are some drawbacks with static capacitors also, like they pose a threat, they pose a problem during switching. uh, High like switching, continuous switching, presence of harmonics in the system may lead to complete failure of protective devices which are related to the static capacitor. So that may be another problem with static capacitors. And phase advancers are also available which we can make use of for power factor improvement. Now we'll try and discuss each of this component in detail. um, Static capacitors, the power factor of the system can be improved by adding capacitors in parallel with the equipment which is operating on low power factor. It may be a capacitor or it also may be a capacitor bank. The capacitor generally draws leading current and neutralizes the lagging reactive component of the load. This tendency of implementation of the capacitor improves the overall power factor of the system. The general scheme of interconnection of the capacitor bank in delta and star is shown in the two or three phase load is shown in the figure here alongside. There is there are some advantages as well as various drawbacks, as I mentioned, of making use of the capacitors. Basically, the first advantage of making use of capacitors is it is the most simplest of the other techniques which we can make use of. Further, they have very low maintenance. Capacitor banks have low maintenance. The losses are also less, and it's easy to install. Capacitor banks being easy to install, and they can work under varying conditions. The drawbacks of the capacitor banks being the lower lifespan, that is typically 10 years. Further, they are uneconomical if damaged due to high voltage. Although the cost is one such important parameter because they are subjected to high inrush currents. Switching, capacitor switching does happen, and it may lead to complete failure or failure of the protective devices which are associated with the capacitor banks. So one should always consider this aspects while installation of a capacitor bank. We'll move to the next mitigation technique, that is making use of a synchronous condenser. Now, synchronous condensers Synchronous type motor generally takes leading current when overexcited and thus behaves. Synchronous condensers, they have very large in size, and the noise which they create, they pose a problem in case of synchronous condenser. Now synchronous condensers are nothing but they are synchronous type machines, motors, which generally takes leading current when overexcited and thus behaves as capacitor. Now an overexcited synchronous motor running on no load is known as a synchronous condenser in normal terms, in general terms. When this type of machine is connected in parallel with the supply system, it draws leading current which neutralizes the lagging reactive component and thus contributing to improvement in the power factor. Now, what are some of the advantages of the synchronous condenser? To begin with, first and foremost, the magnitude of current drawn can be changed to a greater extent, thus achieving superior power factor control. Further, the thermal stability can be attained, and it's easy for removal of faults. Disadvantages of the synchronous condensers include contributing to losses in the motor, higher maintenance cost are also compared to the capacitor banks, and it produces noise as discussed earlier, and the cost is also very high, and further they are very large size equipments, and auxiliary equipment is required for starting. So these are some of the drawbacks of the synchronous condensers. Phase advances. So phase advances serve the purpose of improving the power factor of the induction motors. The phase advancer is nothing but an exciter, AC exciter, and the phase advancer is mounted on the same shaft of the main motor and is connected on the same shaft of the motor as connected in rotor circuit of the motor. It provides exciting ampere turns to rotor circuit at slip frequency. By increasing the ampere turns, induction motor can be made to operate on leading power factor like overexcited synchronous motors. Further, these phase advancers may be adjustable or non-adjustable. It's a source of reactive power connected either to certain junction points in an electric network or directly to the load terminals. It is used to compensate the phase shift between the voltage and the current, the objective being the improvement in power factor. Now, phase advancers make it possible to adjust or maintain the voltage in the network, lower the power losses, and increase the capacity of electric system. As mentioned earlier, they may be or may not be adjustable. Phase advancers make it possible to change the capacitive or the inductive characteristics of the reactive power in a network, ensuring the specified performance maintained even under change in various conditions. Adjustable type phase advancers may be either rotating machine or like static devices. Synchronous compensators may be used as adjustable rotary phase advancers. Capacitors are used as adjustable static phase advancers. Adjustable current rectifiers, adjustable electric reactors or transformers may function as control elements in either type. In many cases, phase advancers also function as load balancing devices. They are like used as filters for harmonic oscillations in the network with predominantly non-sinusoidal loads. And static phase advancers are used in rectifier conversion devices that are triggered. The choice of selection also depends upon um, engineering and economic factors. Uh, they can be conveniently used where synchronous motors are inadmissible. Further, the lagging kVr drawn by the motor are also reduced. And one of the drawbacks which we can mention related to the phase advances being they are not economical for motors below 200 HP, and the nature of the network loads, the rate and the range of load changes and operating conditions of the network. This choice for the phase advances depends on selection of various other parameters. So we can make use of one of the softwares for design of a capacitor bank. Now, as capacitor bank is one of the simplest power factor improvement devices, so one should really focus upon the design aspect of the capacitor. You can make use of, apart from manual calculations, one can also make use of various electric type softwares which are available, like making use of the ETAP software, like apart from the manual calculations, one can also verify the design of a capacitor bank, and also a power system engineer can evaluate the performance of a particular design with respect to various voltage levels, locations, and under various circumstances. Now, it's actually not possible generally it's not actually possible to directly implement a capacitor bank once a particular engineer finds that yes, there is so and so uh, drawback, the power factor being lagging. One of the possible alternatives, and for a small scale application being making use of a capacitor bank, one can't directly go on to install a capacitor bank. There are various literature studies which have to be performed. Before that, one has to evaluate the performance, has to consider the economic aspect, and also various other electrical aspects are to be considered along with that. So making use of a software gives a clear indication to the power system engineer that so and so can be a condition, like making use of a series capacitor will definitely improve the loading capacity. The shunt capacitor is going to improve the power factor of the system, but it also important to maintain the voltage in the permissible limits as per the international standards. So is the importance of power factor uh, governs the relation with the power quality. Improving power factor, apart from improving the power factor by implementation of the capacitor bank, is definitely one aspect, but the other aspects being increasing the capacity of the line. That is one more aspect. Further, there may be certain violations which may happen, and it's never advisable to directly install the capacitor bank without having any previous studies. So these particular softwares, electrical softwares, give an opportunity for the power system engineers to try and explore things. There may be certain other alternatives also, or if a particular power system capacitor bank is designed, uh, how many capacitor banks are required, the operating current, the reactive power requirement, number of banks, considering various other aspects like the design aspects, the load aspect, the shutdown aspect, the backup aspect, etc. Various other things should also be considered. Now, why does power factor is so much important? Why do we have to study power factor so much in detail? Like, first of and foremost, lower utility charges are one such thing. Eliminating the power factor penalty is very important. Like today, as I mentioned, there may be power factor related penalty which can be imposed in the future. That is why it's always advisable to maintain the power factor in certain limits. Like increase system capacity and reduce system losses in our system. Like lagging power factor can lead to increased heating losses also. So considering all these aspects, it's very important to maintain the power factor in the desired limit and make use of modern electric softwares to evaluate the performance after implementation of a particular capacitor bank. So that's it for the presentation as of now. Thank you very much.